To access the workshop content, use your favorite browser and go to aka.ms/Cortana manual. This will bring you to the README file of the workshop content in GitHub. This README file gives you an overview, describes the architecture with functional components to be deployed, the requirements. It also provides a list with links to the instructions of all the exercises that we are going to do in this workshop. Before doing an exercise, you first need to deploy the workshop environment by following the instruction at this link. This brings you to the README file of the setup program. Within this file, it details what to be deployed for the workshop environment. In fact, to deploy the workshop environment is quite simple by clicking Deploy to Azure button here. You need to authenticate with your Azure subscription, and once authenticated in, give a unique name of the resource group to be created for the workshop environment. At some point in time, you will need to acquire a Weather Underground API key to retrieve real-time weather information to be used in exercise 7. At this time, let's deploy the workshop environment. Authenticate in with your Azure subscription credentials. Once authenticated in, give a unique name of the resource group to be created for the workshop environment. In this case, I'm going to give YC-CIS. In a production setting, you should deploy an application environment to a geographic region that is as close as possible to where your target audiences are. In this case, I am just going to select East US, give the same name for the application, and deploy the application to the same region with your resource group. Of course, you do want to read and agree the terms and conditions. And you can also place the tile to the dashboard for easy access to the resource group. Click Purchase to deploy the workshop environment. Azure just finished the deployment, and it presents a list of components that have been deployed, including a virtual machine, a virtual network, machine learning workspace, and also a Spark HD Insight cluster. Now, these resources do incur a cost. It will consume your credit. So the best practice is only deploy the workshop environment when you are ready to do the exercise. At this time, we want to first log in into the virtual machine, and we can do that by go to the property page of the virtual machine, then click Connect to configure the remote desktop configuration. You do have the copy and paste capability once you connect to the virtual machine. You need to authenticate in with the credential that's provided in the instruction. We're going to OK that. Because this virtual machine is not yet been trusted by your local workstation, that's why you get presented with this prompt, because the certificate is not being trusted at this time. If you click this checkbox, it will include this certificate in your local certificate store as a trusted certificate. Then this virtual machine becomes a trusted resource for your local workstation. If you look at the certificate, apparently it is a self-signed certificate because the issue to and issue by the same object, which is the virtual machine. So this is a self-signed certificate created by Azure when they deploy this virtual machine. And we can use this to securely connect to the virtual machine by clicking Yes. Now we have logged in the virtual machine. So let me show you what this virtual machine is by going to Settings and System and About. The OS of this virtual machine is Windows Server 2016 Data Center version 1607. Let's bring our browser session and go to aka.ms/Cortana manual. So we finished the workshop environment deployment, and we are ready for exercise 1, which is to build a machine learning model. There are 9 tasks. The first task is to connect to the lab VM, which I have just done. So I'm going to do task 2 at this time. Task 2 is to navigate to the Machine Learning Studio, and I'm going to open another session and go to studio.azureml.net. This brings up the Azure Machine Learning Studio. We can go ahead and sign in with the Azure credential. Once in Azure Machine Learning Studio, first thing, you want to make sure you are working on the correct workspace. If you have previously created other workspaces when doing other projects, you want to make sure you point to the correct workspace for this workshop. Back to the instruction. That's the task 2. Now we're ready to bring in the data, and this workshop has provided you sample data set, and you can download that from here. So click that. Finish the downloading. Okay, and what we want to do is we want to extract this file. We want to extract this file to a C:\data folder. So C:\data. If the folder is not there yet, it will create one for you. So finish the extraction. We have the data. So we need to upload these sample data sets to the workspace, and then we can start a new experiment. So back to Azure Machine Learning Studio, click Datasets and plus New. We want to upload from our local file, and you can click and go to your data folder on the C drive, and we want to upload all 3 sample data sets. I finished the uploading. Back to the instruction, and that's task 3. Task 4 is to start a new experiment and start building the Azure Machine Learning model. So click Experiments and plus New. This is actually a good page to review. There are a number of sample experiments, and these are good learning tools. I recommend you to review them. For the workshop, we will start with a blank experiment. This brings up a blank experiment, and you see all the modules on the left-hand side menu. These are functional components that you can drag and drop onto your canvas. First, give our experiment a name. I'm going to call it AWT. And if you click the Save Data under My Datasets, these are the sample dataset I have just uploaded. First, I will use flight delays with airport code and simply drag and drop into the canvas. And you can right-click and visualize the dataset. This dataset 2.7 million records. Each record 20 columns or 20 features. Particularly, we care about this departure delay more than 15 minutes. 27,000 records have a missing value. To process the dataset, we can use Python, we can use R script. Let's use an R script. Drag and drop onto the canvas. Connect the dataset as an input for the R script module. Let's go back to the instruction. So task 4, we start a new experiment. Give it a name. And we take the sample dataset as the input. And we also drag an R script module and connect them. Now, copy and paste the provided script to process the dataset for us. From the R script module on the canvas, highlight it and click the double window icon. From here, you can do a Control A to select all and Control V to paste it in. In this particular script, simply remove the rows with missing values, and it also get rid of some of the extraneous information. Okay, that. Now we can execute it to process this dataset for us. You can right-click and click Run Selected, or from here, you can also run the script. This took about 2 minutes to finish. Then next, we want to process the flight weather and visualize the dataset. This one is more interesting. This one has 406,000 records. Each one has 29 columns or 29 features. Examining the dataset, we notice, for instance, the sea level pressure. They're all numerical, but also an M. This is an inconsistent representation of the data. So we need to correct that, replace it with a value, which is what we're going to do in this workshop. Also notice that the feature type or the data type is string. This needs to be numeric. And same thing with hourly precipitation. There's a T to represent trace amount of rain. And this is an inconsistent representation of data as well. We also need to correct that. At the same time, it's also a string data type, and that needs to be corrected to numeric. To process data, we want to use another R script module. You can certainly come here and pick up another one, or you can simply right-click and copy existing module from the canvas and do a paste. And now I just need to change the content of this particular R script module. Let me just connect them, and let's go back to an instruction and find out which script we need to copy. So that's where we are now. And this is the script to process the data set. And right-click, copy. Highlight the module, click double window icon. Control A to select all, Control V to paste. Here, for M, we replace it with the 0.005. For the sea level pressure, we replace the M with 29.92, which is the sea level pressure. And for the precipitation, if we measure trace amount of rain, we replace that with 0.005 inch. And we can execute it by right-click and say Run Selected. Finished. Let's go back to the instruction. For task 6, we will join the dataset. let's first visualize the result data set. Now we have 7 columns for each record. And if you look at the sea level pressure, there's no M. Hourly precipitation, there's no T, and they are all numeric. You look at the wind speed, it's the same thing. Now we can join the data set. Type join. Drag and drop the module. And by the way, if you want to rearrange the canvas, you can simply highlight modules and move them as a group, like that. So now we can connect the left data set and the right data set to the join data module. And we need to select the key columns from each table, from the left and the right data sets. So for the left, airport code, month, day, and departure hour. On the right, airport code, month, day, hour, departure hour. We also want to uncheck this particular checkbox so we don't carry duplicate features. Let's go ahead and execute it. Finished. Go back to the instruction. So we did the join data. And we want to process the joint data set to make sure some particular fields are correct data type. In this case, categorical. So we highlight the script, right-click, copy, R module. And connect the output of the join data as an input for the R script dataset. Click double window icon. Control A to select all, Control V to paste. And we OK that. Right click to execute. It took about a minute to set the data type. Back to the instruction. Now we move to task 7. Essentially, we finished preparing the data. Now we are ready to channel the sample data set into a training model. To do that, we will bring in a split dataset module and split the data. Use part of the data for training, part of the data for scoring the model. After scoring the model, we can validate the trained model that we developed, either changing the algorithm, change the parameters, and maybe come up with a different algorithm, maybe have multiple models. And then you can use an evaluation module to evaluate the performance of your trained model. Okay, so let's go back to the machine learning model. We want to do a split, drag and drop, rearrange the module a little bit. Okay, this is our prepared sample data set. So I'm going to take this as an input into the split data. The split data module will, based upon the value we provide, split the data for us. Part of the data are for training the model, other to score the model. So to do that, we can specify the fraction. 0.7 represent that 70% will be for the training and 30% for scoring. And let's go ahead and execute it. Finished. Now we can bring in the train model, which is right here. Now this train model will take the 70% of the sample data set, but with what algorithm? In this particular workshop, the instruction shows use two-class logistic regression. Two-class logistic regression, so drag and drop that into our canvas. So use this as an input for the train model. This train model will use this particular algorithm to identify the correlation between those features in a sample data set. But then learn for what? Learn to predict what? That's why you see this red check mark here. We need to specify, we need to tell the train model to train about what? You want me to predict what? So let's go ahead and specify that. What we care about is the departure delay more than 15 minutes. So we're going to select that as the label, which means to make the prediction for this for me. And then after you train the model, you want to score the model. So the output of the train model will be the input for the score model. This is 70% of the sample data for training, and then the 30% to try to make the prediction based upon what we learn from the train model. All right, let's go ahead and execute it. All right, this took about a little bit more than a minute. Then you can use an evaluation module to evaluate the performance of a train model. In that case, we will connect the output of score model as the input for evaluate model. Right-click to execute it. Finished. This took about 40 seconds. Let's right-click and visualize the results. Here, you have the ROC curve, the precision recall lift. You also have the confusion matrix, F1 score. So you get the evaluation of the score model. If you have multiple score model, you're going to see multiple curves here. And that is pretty much your machine learning model. Again, what we have done, we're bringing in the sample data set, we prepare, we correct, we take care of the missing value, the inconsistent data representation, incorrect data types, things like that. And once we finish preparing the data, we then split the data. Here we use 70% to train and 30% to score. And for the train model, we use two-class logistic regression. For different type of problem, you will use different type of algorithms. Back to the instruction. Okay, train model, score model, evaluate model, all right, and then you have the results. You can then package the Azure Machine Learning model as a predictive web service, which is what we are going to do next. By the way, you should save the model frequently just to make sure. So we are ready to package this machine learning model as a predictive web service. But before we do that, we need to run the entire model. Because if you recall, along the way, I simply run selected, validated changes along the way. So this time we need to run the entire model by clicking run. We're done. And this is the entire model. If you want to rearrange it, again, you can highlight the module and move it as a group. Right? If you want to line it up nicely and things like that, you can do that. Okay, so we're all good here. Now let's go ahead and repackage this as a predictive web service. All right, it finished. Now it added a web service input and a web service output and combined the train model with algorithm into this AWT trained model. Okay, let's zoom in a little bit on the input part. So let's go back to the instructions, see what we need to do at this time. All right, so we did that. For the web service input, we need to disconnect that and move it to near the join data. So let me show you that and I'll explain. So basically what happened is for the web service input, we really want to direct this towards our end of data preparation. Does that make sense? So you get the input data from the web service and then you feed it into your machine learning model. Let's go ahead and disconnect this. And we want to move this module to near the end of preparation of our data. So let's say I want to leave it here. Okay. Remember, after we join the data set, and then before we feed it into the Azure Machine Learning model, before we feed it into the score model, here's where we set the data type of selected features as categorical. So what we want to do is, let's go ahead and delete this. So we will do this. We will connect this in. So we want to connect the web service input as an input before we feed it into the score model, just to make sure that we have correct data type of the selected features. For the joint data set, there's one more thing we need to do. Because what happened is, remember when we pick up the sample data set and feed it into the train model, we have it predict the departure delay more than 15 minutes. Now, in the web service model, that departure more than 15 minutes is what we want the model to predict. So we actually need to exclude that particular feature. We want to add another module here to exclude the feature we want to predict. To do that, we use select column. So I'm going to drag and drop that one and connect the output of the join dataset as the input for the select column module and the output of the select column module as the input for the R script module. For the select column module, launch the column selector and click all column, and we want to exclude. We want all the columns but exclude the departure delay more than 15 minutes. Let's go ahead and process that first. Finished. This took about a minute. So let me just see the entire model and let's make a little bit rearrangement. Just put this one here and let's just put this one here. All right. So what we have done, we exclude the feature that we are trying to predict, and we move the web service module sort of to the final preparation of the data. Now let's go back to the instruction. So exclude the departure more than 15 minutes. Put in the select column module. Connect the web service input. For the output, we want to be able to show the airport on a map. For that, we need the longitude and latitude information, and there's a table that's been provided as a sample data set for us to do that. So after we score the model, we are going to make a join with this particular table such that we can have the longitude and latitude information for the airport in the scored data set. So when we actually show the prediction of the delay, we can show those airports on the map. That's what the joint data module is doing. So let's go back. So I want to bring in a joint data module. Drag the joint data module here. We also need to bring in the sample data set, airport code, location, lookup table. So we want to join this one with this one. Okay, and let's go and disconnect this one. And I think I may have to arrange it differently than what the instruction asks us to do. Yeah, okay. I want to make the airport code lookup table as the right table. Let me just rearrange that to make sure we're consistent with the instructions, so I won't confuse you. So let me just delete that connection. Remove this here. Delete that connection. So I want to connect the score model as the right input and the airport code location table as the left input. Okay, and let's select the join key. That will be airport. So airport code for the left, airport for the right. And again, we want to uncheck this particular checkbox so we don't get duplicate key from the right table. Let's right click and execute that. Finished. It took about a minute. Let's back to the instruction. All right, on step 17, we want to eliminate some of the columns, some of the feature that we don't need, and also we want to change the heading. Let's copy and paste that. We want to bring in another execute R script module after we join in the data. So connect the output of the join data module as the input for the execute R script module and click the double window icon. Control A to select all, Control V to paste. And we're going to OK that. Right click to execute. Finished. This took a little bit more than a minute. So we're almost done. Let's go back to the instruction. And the final step is to add in web service output for task 8. So web service output, and we will connect the output of the execute R script as the input for the web service output. Let's go ahead and save it. That is our predictive web service model. Back to the instruction for task 9, which is the final step. Now what we need is to generate the URL, the encryption key, so we can consume this predictive web service. Okay, to do that, we need to run the entire model. Remember, along the way, I just right-click and run selected. So we need to validate the entire model by doing a run. And this only takes seconds. So we're done. Now we can deploy. And we want to deploy web service new. This brings up the quick start page, I guess. Okay, from here, first you need to specify a price plan. If you have not created a free plan, then you can have one and only one free plan. Or you can use a different service plan. Here, let's go ahead and create a free plan, and I'm just going to call it free plan. And click deploy. So it will deploy using this free service plan. And there's some restriction to it. For instance, 1,000 transactions, 2 compute hours. Yes, quick start page. Here, we want to select used web service, and it generates the pertinent information that we need to keep for this workshop. So primary key, request response, batch request URL. We want to keep the information handy so we can use it later in exercise 4 and exercise 7. So I'm going to right click on the desktop and create a text file. I'm just going to call it awt.txt. And what we need to copy in is primary key, request response URL, batch request. We also need to prepare workspace ID and service ID. So copy the primary key, paste it in. Request, response, URL, copy. And the batch request, let's copy that. For the batch request, you want to delete everything under the jobs, including the question mark. I want to delete that. The workspace ID actually is the string after the subscriptions right here. So copy, paste. That's your workspace ID. Service ID is the string after the services right here. Copy, paste. Let's go ahead and save the file. Close it. Let's go back to the instruction. Right, the quick start page. Get all the information. And this is the end of task 9, which is also the end of the exercise 1.